So in this video, I'm just going to illustrate how you go about using the information found here on this ski jump to figure out the total mechanical energy. Just remember that total mechanical energy is equal to the kinetic energy plus the potential energy. So for the total mechanical energy at the very top of the mountain, again our equation is total mechanical energy is equal to the kinetic energy plus potential energy. So for the top of the mountain, we're going to use these figures up here. So the kinetic energy is 0 joules, so the energy of motion before she goes down the slope is 0, plus the potential energy, which would be 50,000 joules. That's what potential, the energy of stored position, and that would give me an answer of 50,000 joules for the total at the top. If I just want to figure out what the total mechanical energy is at point A, right here, and we're going to use these figures here. So again, I have my equation. The total mechanical energy is equal to the kinetic energy plus potential energy. So in this case, the kinetic energy is 35,000 joules plus the potential energy of 15,000 joules. And we just simply add those two together and we get 50,000 joules for the total. Once again, kinetic and potential can only be the total. For point B here, we'll use these figures here. And again, my equation is the total mechanical energy is equal to the kinetic energy plus the potential energy, which would be here, the kinetic energy is 20,000 joules. The potential energy would be 30,000 joules. And again, it adds up to 50,000 joules. Nothing's created or destroyed. It's always going to come back to the total that we started with. Finally, on this one at point C here, we'll use these figures here. So again, total mechanical energy is equal to the kinetic energy plus potential energy, which would be, in this case, 50,000 joules of kinetic energy plus 0 joules potential, which would give me again 50,000 joules.